This is AQA GCSE Chemistry. It is the trilogy paper, the higher trilogy paper from 2018. It's paper 1 and this is question 3. And the whole question is actually here for you to see and try for yourself before you review. Okay, so a student plans a method to prepare pure crystals of copper sulfate, and the method is provided here that student came up with. Add 1 spatula of calcium carbonate to dilute hydrochloric acid in a beaker. When the fizzing stops, heat the solution with a Bunsen burner until all the liquid is gone. Now there are many errors in there, and it would not produce copper sulfate crystals. What improvements could be made? Now, it is a 6 marker, so we're looking at the levelled response. To get a level 3, you need relevant points, reasons and causes identified, detail and logical links to form a clear account. Right the way down to level 1, where there are some points identified, simply stated, but they're not necessarily relevant or it's not clear how they're relevant, and there are no links between the things that are said. Now, in terms of the indicative content, there are a number of things, as already been pointed out. We're making copper sulfate, so we would not do that with hydrochloric acid. We would use sulfuric acid. Similarly, if we're making copper sulfate, it makes no sense to use calcium carbonate. We would need to use copper carbonate instead of calcium carbonate. You would add not just 1 spatula of calcium carbonate. You would then stir, and then you would add more, and you would continue adding more until there was an excess of the solid, because that would tell us that the entirety of the acid had reacted. And because we've done that, we would then need to filter to get rid of the excess solid. So we are seeing here a fairly standard methodology that you will have come across within lessons. And finally, we've got the fact that we're heating until all the liquid is gone. Well, actually, you heat gently and you only do that until around half the liquid is gone, or certainly some of the liquid is gone. And you then allow the remainder of the evaporation and crystallization to happen more slowly, potentially at room temperature. And that takes us to the end of that question.